Hi, dear students. Let's talk today on soil structure. As we had mentioned in the previous class, we know that soil mainly consists of three main particles. It can be of either sand, silt, as well as clay. And these three inorganic particles, along with various other organic particles, get interact with each other and they can form in either they can occur different in some structures like aggregates can be formed. So these aggregates, as we mentioned, they can be either be occurring by natural processes or they can be occurring by artificial processes like plowing, tilling and all that. When these aggregates they occur by natural processes, they are referred to as the beds. And when they occur by artificial methods involving human interference, they are referred to as the clods. And all these beds as well as the clods, they play a very important role in contributing to the structure of the soil. Now, you might think, what is the structure of the soil? The structure could be of either two forms. Either they can occur as structureless forms, that is, no beds would be there in that. That means no aggregates would be there in the soil, or they could be structured forms. And the gradation of the structure formation would be different. Now, some would be medium-sized structures, some could be large and all that. It depends upon the number of interactions or the number of aggregates or the number of beds or the number of clods which have been formed. The structure of the soil will be found to be different. So let's just explore all these in the PowerPoint, which is coming ahead. Let's see that. So this is what is the soil structure as we mentioned earlier. They could be either formed as aggregates or they could be formed beds when they occur as naturally occurring aggregates, or they could be by artificially by plowing and all that. And you can have a look onto this. See, you have organic matter here, you have clay particles, you have silt particles as well as the sand particles, which are being clumping together to form aggregates here. And you can see, other than the various methods like plowing and all that, we can also have various of the natural techniques like freezing, thawing, wetting, drying, as well as by the fungal activity. Uh, you can find aggregates of the soil. Now, coming to the structure, as I had told earlier, you can either form two different forms. A structureless form, which is a large soil, solid featureless mass, referred to as a massive, and they have little or no structure. And in the case of the structureless forms, no beds are being formed. You don't have to confuse with beds. Beds means only thing that no naturally formed aggregates are there. And for sandy soils, they have no structure because the sand grains do not cling to each other. And sometimes you can also consider the soil to be as good structured soil. Okay, good structured means it is having lots of beds. That's the meaning. And the good structure is very much important as it allows the water to soak into the soil and excess water to drain away. And it also allows air movement through the soil. And we know that soil, air, as well as water is essential for the healthy plant growth as well as the nutrient supply. So for a fertility point of view, a good structured soil would be more preferred than a structureless soil when we have to consider the agricultural growth. Coming to PEDs, as we saw in the picture earlier, they are consist of mineral particles, clay, silt, sand, and they are mixed along with the organic matter. And in the PEDs, these are being held together by electric charges on the surface of the minerals as well as the organic matter. And uh, you can see that although clay particles are small, they have a large surface area, and the surface on the clay in a teaspoon or a black cracking clay soil is equal to the surface area of a tennis court. Such amount of interaction happens within a clay. And such clays and soil with a lot of organic matter are more likely to form strong beds. Sandy soils or soils with little organic matter have little or no pet development. And we can see that so it's basically based upon the more interactions which happen in the soil, or the more binding ability or the charges which happen between the soil, the better of bed formation, or the better interactions happen, resulting in the formation of stronger beds. And you can see that these beds can be of different shapes. Like they could be, that's nothing, beds are the natural aggregates of the soil. They can be either blocky, they could be columnar, they could be massive, they could be simple grains, or sometimes they could be even platy. Now, what are all these? Don't get scared. It's nothing but the shapes in which the soil is being found. Either they can be formed as blocks, as we see in the A, or they could be columnar, as we see in B, or they could be massive, as we see in C, or they could be a single grains in D, or they could be platy, as we see in E. And if you go to describe the soil structures, now that's what we told about the beds. Now, if you go to deal the soil structure, basically, there are 8 different forms of soil structures. As we mentioned earlier, they could be block-like, or the soils can be columnar. As we see, the units are similar to the prisms, or they are bounded by a flat or a slightly rounded vertical faces. And the tops of the columns are very distinct and normally rounded, sorry. And it could be crumb, that is small, porous and weakly held matter could occur. They could be granular, where the units are approximately spherical or polyhedral, and they are small, non-porous and held together strongly. Or the soil can be massive, as we think it is having no apparent structure, but they have been held together in a large uniform masses. That is, when the soil samples have been held together in a big mass, that is large amount of soil is being connected together, we call it as massive. Or it can be platy, that is, it will be flat and plate like. Or it can be prismatic, where they have been bounded by flat surface. You know how a prism looks. A prism has got different flat surfaces. So the same way the soil is being held together and they have flat surfaces. And they could be of single grain. That is, there is no apparent structure here. The soil particles exist as individuals and they do not form aggregates. So as a whole, if you're going to consider the soil structures, we have different types. There are 8 different types. Either they form blocks, okay, they can be flat or slightly rounded surfaces, that can be there, or they can form columns. You know how a column looks. It could be either flat or slightly rounded, or they could be crumb. Crumb are the ones where small, porous and they are being weakly held together. Okay, crumping means they can break down easily also. And coming to the granular one, they are just spherical or polyhedral, and there are small aggregates, but they are non-porous and held together strongly. So I guess rather than telling you this, if you look into the picture, it has been found to be more clear. You can either have a granular version like this, a crumb version like this, a platy like this, and when it forms a prismatic one, it's like this, where surfaces are being present. Or it can be blocky, or it can be columnar, or it can be massive or simple grains. Hope so this is clear to you. So with this we come to an end of the soil structures.